Okay, so I come to section 10.5, more radical functions. So let's talk about recognizing root function and their properties in here. In the first picture in here, you can see the square root function. Okay. So from the square root function, you can see that the domain of the x is start from 0 over here. And it should keep going to positive infinity later, right? You can see that. For the next one, in the right hand side here, there is cube root function. So the graph is come from the left to the right. It's been what? The domain is from negative infinity to positive infinity. There's no hole, no gap, no jumping at all. All right. So let's move to the next. The next picture over here is the for root of the function. So you can see and compare the for root and the square root is look like, you know, just come from 0 to the positive infinity. But for the square root, it look like it's go for the value of y, it's go higher and higher quickly. But for the for root, it's go higher but slowly. And also for the value of x, it's just from 0 to positive infinity, right? You see that. Similarly, with the fifth root, this is odd, right? It is even root, okay? And it is even root. It is odd because this is third one, right? You can see that for the fifth root, it's also like go from left to the right. So from negative infinity to positive infinity for the domain, right? But it looks like it's flatter. It's become flatter and flatter from 3 to 5, right? You see that? Okay, so let me write out some common. Firstly, note that the domain for an even root function is always from 0 to positive infinity, inclusive 0. Second one, let's say the domain for an odd root, function is from negative infinity to positive infinity. Number 3, the higher root the more slowly the graph. increase. The more slowly the graph increase. So for x greater than or equal to 1. Okay. So let's move down to the example number 1 over here. I am doing evaluating root function. So from A, I have fx equal to square root of x plus 1, and for x equal to -5 and x equal to 3. So let's have x equal to 5 first. Substitute into f of x, right? So evaluate mean you just gonna substitute the value into the function. So you have f of 5, right? X now, f of x now become f of 5 equal to square root of 5 plus 1. That equal to square root of 6. That should be the answer for the first one. Oh, actually, it is a -5. Sorry. Okay, -5. So -5. So -5 plus 1 is equal to 4. And square root of 4 will be equal to 2, right? Next one, I have x equal to 3. Substitute into f of x. I have f of 3 equal to square root of 3 plus 1 equal to square root of 4 and equal to 2 also. Okay. Oh, shoot. I make a mistake over here. It should be a -4. Oh, okay. Okay, got it. Sorry for that. So it is square root of -4. What happened? That's why I cannot do this. Square root of -4. It is not this is not a real number. Okay, this is not a real number. For x equal to 3, substitute into f of x equal, so you're gonna have 2, right? Okay, let's move to the B. I have maybe move up a little bit. Okay, so I have f of x equal to square root and cube root of 1 minus x. And now for x equal to -7, substitute into f of x. What do I have? F of -7, and I have cube root of 1 minus for -7. And that gives me cube root of 1 plus 7. That's give me cube root of 8. Cube root of 8 equal to 2. And that should be the answer. I should also have circle this, circle this, circle this. Okay. And for x equal to 28, substitute into f of x. I have f of 28 will be equal to cube root of 1 minus for 28. That's going to give me -27. That's going to be equal to -3. Because -3, cube root of -3 gonna be -3 to the power 3 gonna be equal to -27. Okay. Okay. So let me circle this. In order to use calculator for this problem, A3. Let me show you how to do it. So for example, if I'm trying to find square root 4, you should know that for square root, click on the second and the 0 button, the x square here, we're gonna be square root 4, and we enter. That's equal to 2, right? For the cube root, there is no cube root, but you should understand that the cube root gonna be just power 1 over 8, 1 over 3. So I'm gonna put down 8 to power 1 divided by, divide by 3, and close the parentheses. And this is 8 over 1/3, which means the cube root of 8. That gives me also 2, right? And for the negative 27 cube root, so I have to have parentheses. I put the negative over here, 27, and then closes, and to power 1, should have the parentheses first. 1 divided by 3, and that should be cube root. And that's give me negative 3. So that's a way to use calculator for this problem. Let's move to number 2. And we're gonna recognizing power function in their properties. For the power function, if a function f can be represented by f of x equals to x to the power p, and p in here is a rational number, okay? So p in here has to be a rational number. And then f gonna be a power function. If p equal to 1 over n, where n greater than or equal to 2 is an integer, okay? And then f also a root function, and we given by fx equal to square root of root n of x. So in the case that n is greater than or equal to 2, and with the integer as an integer, so then that should be a root function also. Okay, and also the p in the form as 1 over n. Okay, so let's move to example number 2. We evaluating power function. So similarly, at the example 1, I'm gonna have like x equal x equal to 16, and then plug into fx. We have f of 16 will be equal to 16 to the power 0.75, right? How can you calculate this guy? You're going to use calculator. Okay, so you have 16 to power and 0.75, and you have 8. 8 gonna be the answer. Easy. This problem, I would say just do calculator. It's easiest. Okay, so let me see. So column B, column B, I also gonna plug x equal to negative 81, plug into f of x. So we have f of negative 81 will be negative 81 to power 1/4. Remember that with n, which is a denominator, as a even number. Let me see. N in here is an even number. then the base x should not be a negative number. It should be like a for this one it will give you like a not a real number. Okay, so so I'm gonna say this is not a real number. Okay, this is not a real number. um, um, because uh, because I'm gonna say root 4 root of negative 81 is not a real number. Okay, so we have finished this problem B, and we move to say 3. No, just say graphing power, graphing of the graphing power function. So you can see down here I have like a 3 graphing. We have the first one have x power 1/3 and x to power 3/4 and x power 7/5, right? So I would love to have one more requirement that x for x is greater than 0. Let me see. No, let me say for x is greater than 1 and x is just from 0 to 1, not inclusive. Okay, and see what happened, right? So for the first k I have p equal to 1/3. Second k I have p equal to 3/4, and the third k I have p equal to 7/5. So I can see that from here, if x greater than 1, I'm gonna have as for x, and then x to power 1/3 gonna be less than x to power 3/4, and gonna be less than x to power 7/5, right? You can see that it's go higher and higher. So we're gonna say like larger exponent, and then faster graph. Okay, so in the case that x greater than 1, for the case that if x is that's x in between 0 and 1, what do we have? We have x to power 7/5 going to be less than x to power 3/4 and less than x to power 1/3. So we're gonna have a smaller exponent and it's going to be a larger y value. This is for the R3 graph in here is for x greater than 1. I didn't have the graph that from 0 to 1, but you can check on Desmos. Make sure that there's one more thing that you need to remember is all the graph have to be all the power graph gonna pass through point 0, 0 and 1, 1. So so that's gonna be what I want to tell you today for 10.5. So I'm gonna stop 10.5 here and see you in the next section. Okay.